Hello everyone. Today we're gonna do a practice of one of the lead code question, and I will try to solve in a similar way like how I solve in a actual interview. So this is a famous question, which is diameter of a binary tree. So the question in this question, we need to find the diameter of a binary tree. We need to find the longest diameter of a binary tree, and the definition for diameter of binary tree is the longest path between any of the two nodes. And it says this path may not pass through the root node. Now, in this given example, the longest path is 4213, so which is 3, considering like one path from parent to child or child to parent is equal to 1. So this is 4 to 2, 2 to 1, and 1 to 3. So this is 3. Now we'll go to one example also where actually the path may not pass through the root node. So let's take this example. Let's suppose 1 is the root node and it has left child as 2 and right child as 3, and then 2 has left child as 4 and then right child as 5, and then let's suppose we go below 4 and we have 6, and then below 5 we have 7. So now the path from 6 4 to 5 7 is 1 2 3 4 1 2 3 4. So this is equal to this path, so we'll take two more childs here, so 8 and 9. So if we take example now, the longest diameter is 8 6 4 2 5 7 9, so which is 1 2 3 4 5 6, right? So 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 if we given a tree, the longest diameter in a given tree is basically longest diameter passing through root, or it is longest diameter in the left subtree, or it is longest diameter in root right subtree. So basically we need to maximize three of them. So here we need to find out longest diameter passing through the root node. So longest diameter passing through the root node will be equal to, can be defined in terms of depth of the left subtree and the right subtree. So if we are at 1 and the diameter passing through this would be 1 starting from 8 to 10 going to 3. So this can be written as, so depth of the subtree plus depth of right subtree. So here we need to do maximize. Right, and we know that depth of any root is equal to max 1 plus max of depth of root dot left subtree and depth of right subtree. Right. So we so one brute force is like we start from this node and try to run this algorithm, and then we go to 2, and then we basically go to root left, which is 2, and again recursively try to run this algorithm, and then the complexity that will be O of n square. So it is one solution, but it's not the most optimized solution. If you see, right, we are traversing this tree again and again. So for one, we traverse this subtree, and then for 2 again we traverse left subtree and right subtree. So what we can do is we can store these results, right? So what we can do is like we store this result and do a traversal from bottom up. That is, we go to left subtree and then we go to right subtree and then we go to root. And in each time we basically find out two things: depth and the diameter. So we find out diameter and the depth. right? And so since we are traversing, if we traverse from bottom up approach, like for computing 8, the 8 is a leaf node, we can compute something both diameter and depth for 8, and similarly for 9 also we can compute. And if we have results of 8 as ready, then we can compute for 6, and if we have results of 6, we can compute for 4. And similarly, if we have 9, then we can compute for 7, then we can compute for 5, and we can compute for 2 if we have results of 4 and 5 ready. So in this way, if we do this bottom-up traversal, we can compute everything in O of n. So, so we'll go and write, we'll do this kind of traversal. So for doing this kind of traversal, we first need either pair, or I prefer creating a class which makes the code more neat and clear. So I will have a diameter and it will have depth. So since it's a Java, I need to create a constructor. Right. Now I need to create a method for DFS. So I will call it traverse, and it will have tree node, it will have root. So base case, if root is equal to null, so if we reach the end of the tree, then we'll return a result, and this will be diameter is equal to 0 and depth is equal to 0. Now let's suppose there is something, then we will find out the left result. So left result is stored in a variable, and we'll do traverse root dot left, and similarly we'll find the right result, and we'll have root dot right. Now we have the left hand result and right result. Now we need to find the diameter. First we'll try to find out diameter passing through the root node and the node. So for that, what we said, like, it is the depth of left subtree plus left depth of right subtree. So depth of left subtree is left result dot depth, and depth of right subtree is right result plus depth. And then this is not the only possible answer. So our answer might be lying in the left subtree and right subtree. So left subtree. So we need to find out max of 3 things. So we'll write mat.max actually left result dot diameter, and then we'll have right result dot diameter. Correct. Right, and then we need to find out depth. So depth will be equal to, so depth we said will be this. Either we need to find out which is bigger, like left or right, or left subtree or right subtree, and I'll add 1 to it. So we'll have 1 plus mat dot max left result dot depth, and right result dot depth, and then we'll return a new result. Here we'll pass the diameter, and we'll pass the result for depth. And here from the initial function, which was diameter of a tree, we'll call the traverse method with the root node, and it will return result, but we need to find the diameter, which will be integer, and we'll return this. Right, so let's take this example here and try to find out if this example works for us. So we'll start with the node 1 here and call traverse. So we call traverse with 1. So this condition becomes false, and we basically go to left subtree. So we'll have 1, and we're going to left subtree, and the next step of the stack would be we'll start with the 2 traverse method. So we push 1L into the stack, and then we'll have 2. So this is null, so we again reach to 2. So again we get 2L here, and then we basically similarly do 4L, 6L, and till 8L do. And when we do 8L, like we go to the side which is null, so we enter this code with null, and here we get 0 0 as the response from the left side. So 0 0 we got from here, and then we go to 8R side. So again, we get 0, 0 response. So we go to this diameter code. So diameter says that either we'll take the left depth plus right depth, which is 0, 0, 0, and we'll do another max with these two fields, the diameter left subtree, diameter right subtree, everything is 0. So answer that we'll have will be basically 0, 0. So we'll have 0 comma 0 is the answer, and this will be returned to 6L. So 6L will now go to right. So right side is null, so we know the result of the null will be 0 comma 0, 0 comma 0. Here now, sorry, so when we were 8, like depth was 1 plus left depth, which is 0, and right depth, which is 0. So here the left side result was 1. Right, so now we are at 6. We need to compute the diameter. So diameter will be max of left depth plus right depth, which is 1, which is 1 plus 0, 1. And then we'll compare two zeros here and we'll have 0. Then we compute the depth, which will be 1 plus left depth, which is 1. So this will be 2. And 1 plus 0, which will be 1. So answer will be 2. So we'll return this to 4L. Now we go to 4R. 4R again is null, so we know the answer of null is 0, comma 0. So depth of this, so we need to find the diameter. Diameter will be 2 plus 0. So 2 plus 0 is 2. And then we need to compare with the left diameter and right diameter. So this is maximum. So we compute depth. So depth will be 2 plus 1, 3, or 1 plus 0, 1, which will be 3. So now we have 2, comma 3. Now we return to 2L. So 2L will be 2. Now we go to right side of 2. So we go to 5L, and 5L will be 0, comma 0. And then we go to right side of 5, which will be 7. We go to 7L. 7L will be 0, comma 0. Then we go to right side of the 7, which is 9. So we go to 9. So 9, the leaf node, just like 8. Answer will remain same as 8, which will be 0 comma 1. So since diameter will be 0, but depth will be returned will be 1. So we again reach to this point where at 7 we need to calculate the diameter. So diameter will be 0 comma 1. So diameter will be 0, 1 plus 1, 1 plus 1, which will be 2. And sorry, 0 plus 1, which will be 1. And we'll compare with 0 and 0. So the diameter will be 1, and the depth that will be computed here would be 2. So now we go to now, so this will be returned and reached 5 node. And at 5, again, we are at this point. We compute the left result depth, which will be 0, and right result depth, which will be 2. So this will be 3, this will be 2. And we compute the depth, which will be 1 plus max of this, which will be 3. So we'll return 2 comma 3 to here. Now we have 2 comma 3 and 2 comma 3 at 2 node. So we'll have the diameter here will be left depth, which is 3 plus 3, which will be 6, and the depth will be 1 plus 3, which will be 4. So both are 3, so it will be 6 comma 4. Now we'll go to that will be returned to 1, and then we go to right side, which will be 3, and 3 we know it's a leaf node, so we'll get the same answer as 8 and 9. So 0 comma 1 will be returned. And now we'll be at this point. We compute the diameter. It will be 6. So diameter will be 4 plus 1, 5. 5. And and we compare it to the left diameter, which is 6, which is, so this is greater. So we'll replace it with 6, and this will be smaller, so it will be ignored. And compute the depth will be 1 plus maximum of these two, which will be 5. So 6 comma 5 will be returned, and hence the answer will be 6. So let's try to run this code. Now it has some compilation failures. It's a typo here. I hope this time it compiles. It's okay. It should be public. Great. So this test case is passed. Let's try to submit this code. So it passed. It says it reached 28%. So let's try to see other different solutions. So So, so we have height, and so I think it's doing the same thing. So this guy has written the height function, so it's traversing bottom to up, and then we are basically trying to do diameter computation at each step of height. So like it's very comparable code. Like few if else we might be having extra, the complexity overall remains same. So thank you guys.